Hello everyone, I'm Peizhang from Red Hat. I will show the demo about confidential containers bare metal solution and fraud detection in Red Hat OpenShift AI with confidential containers. We call confidential containers CoCo. Let's go to the CoCo bare metal solution part. This is a solution overview. We mainly have three parts: bare metal, assisted installer, helper scripts. So first, we need to prepare a bare metal server with TDX or SMP enabled. And then we can install the OpenShift cluster with OpenShift sandboxed containers operator enabled with the assisted installer. Next, we prepare the two helper scripts. One is set up CoCo and the other is set up Trustee. After all these three parts are set up, we will have a basic CoCo bare metal environment. Next, let's say the assisted installer. The assisted installer is an installation solution for the OpenShift cluster. It's offered on the Red Hat Hybrid Cloud Console. The assisted installer supports various deployment platforms, including the bare metals and others. In today's demo, we will deploy on our TDX bare metal. Currently, the OpenShift sandbox containers operator has been supported in the assisted installer, and you can see in this page it's supported as technology preview. So the users can install the OpenShift cluster with OpenShift sandbox containers operator enabled on bare metals using the assisted installer. Next, let's start deploying the OpenShift cluster with the assisted installer. This is the assisted installer web page. A clarification about the web link. This is an assisted installer local deployment because the latest assisted installer version, which supports OpenShift sandbox containers operator, has not been released when we record this video. However, it will be released soon. Now let's create a cluster. Let's import the cluster name as CoCo demo, domain name, OpenShift version, and pool secret. Let's choose the number of the nodes we install SNO. This is the operator type. We choose we enable the OpenShift sandbox containers operator. Let's add the TDX bare metal. Let's choose the minimal image file and paste our public key. The public key will be used to log into the OpenShift nodes. Generate discovery ISO. Now let's download this ISO and install this ISO on the TDX server. During the ISO installation, let's keep watching the host discovery. The ISO installation is ready and the node is discovered. Let's continue the installation. Now the installation is in progress. In the operator, we can see there is a pending operator, OpenShift sandbox containers. The installation is finished. So this is the way how we install the OpenShift cluster and install the OpenShift sandbox containers operator in the assisted installer. Now let's get back to another part of the solution overview. Another part of the solution is install helpers. We prepared two scripts. The first one is set up CoCo and bare metal OpenShift worker nodes using the OpenShift sandboxed containers operator. And this script is in this link, and it mainly deploys node feature discovery operators, kata-tdx or kata-smp runtime class, and Intel decap related setup. The second script is set up the Trustee. This is the script link, and it mainly deploys Trustee and Intel Trust Authority. Here is a note. In today's demo, we will deploy the ITA on the TDX server. So when we deploy these two scripts, we need to export the two environment first. One is PCC as API key, and the other is ITA key. We can get this value from these Intel links. Now let's export the config. This is the TDX bare metal server. Source the environment which exports the PCCS API key and ITA key, as they are private info, so I'm not sure the details of this file. Now let's clone the sandbox containers operator repo. Let's go to the directory of the scripts. TDX. Let's run with TDX. The CoCo installation is finished. Now let's check the runtime class. We see there kata-tdx. Next, let's set up the Trustee. Let's go to the scripts installer helpers directory and start the installation. Now the scripts is finished. Let's check the Trustee operator pod. They are running. So up now we have deployed the CoCo and Trustee ready. This is how we deploy them. And we have a basic CoCo bare metal environment. Next, let's deploy the fraud detection in OpenShift AI with this CoCo environment. So what's the fraud detection? The fraud detection model monitors credit card transactions for potential fraudulent activity. It analyzes the following credit card transaction data, including the geographic distances, the price of the transaction, how the user completed the transaction by using the hardware chip or a PIN number or online or offline. So by analyzing this data, compare the current data with the history data, the model outputs the likelihood of the current transaction being fraudulent or not. So this link is a fraud detection workshop link. This picture shows how we deploy the fraud detection AI model on OpenShift AI with CoCo. There are generally three phases. The first phase is we develop and train the AI model in the Jupyter notebook. There are several sub-steps. create the AI model and encrypt the AI model, encrypts the AI model, and after the AI model is encrypt, we let's go to the second phase is that uploads the encrypted AI model to the main IO pod, which has a S3 compatible storage. So the third phase is model serving. The inference service pod, it will download the encrypted AI model from this storage, and then it needs to retrieve the key from the trustee, which we are used to encrypt the model. So with CoCo, it will retrieve key from the trustee, and in our demo, we are using the IT as attestation service to release the attestation token, and the trustee release the key to the pod, and the encrypted AI model can be decrypted, and then it would be able to run. So this is with kata-tdx CoCo pod. Also, in our demo, we will show non-CoCo pod. The default runtime class of OpenShift is runC, so we name it as runC pod. The first phase and the second phase are same. The difference are the third phase. So after the encrypted AI model is downloaded, it needs to retrieve the key from the trustee. However, if the runC pod is not in a TE environment, so it fails to perform the attestation, and it fails to get the key. So the AI model cannot be decrypted, so it cannot be run. So in a summary, with kata-tdx, the encrypted AI model can be decrypted and served, but with the runC pod, the encrypted AI model failed to be decrypted and cannot be run. So we will show this in our demo. Now let's open the OpenShift cluster to deploy the fraud detection. We can click the web console from here. So we have several operators installed. The Intel device plugins operator, the NFD operator, OpenShift sandboxed containers operator, and confidential compute attestation operator is installed by the assisted installer and the helper scripts. And for the fraud detection, we manually installed the OpenShift AI operator, OpenShift serverless operator, and OpenShift service mesh operator. Now let's open the OpenShift AI web console from here. The network issue, so I just refresh to get the OpenShift AI page. Here I created a fraud detection data science project, and there are several tabs in the fraud detection projects overview, workbench, pipeline models, connections, and others. What we used in today's demo is connections, workbenches, and models. So the connections is storage. When we train the AI model, the AI model will be uploaded to the main IO storage, which is S3 compatible storage inside the main IO pod. So we connected this storage to the fraud detection workbench. Here is the workbench. Let's check. I have created it in advance. So let's say the workbench, the name fraud detection, its notebook is TensorFlow, and it's connected to the my storage. So the workbench is an isolated area where the people can work with models in their preferred ID, such as a Jupyter notebook. The users can add data connections or configure cluster storage and others in their workbench. So here I opened the Jupyter notebook. a simple introduction about the Jupyter. The Jupyter Lab is a web-based interactive development environment for notebooks, code, and data. Its flexible interface allows users to configure and arrange workflows in data science, scientific computing, computational journalism, and machine learning. It supports many languages and kernels and work with front ends including the web application Jupyter Notebook. So we download the fraud detection repo and it's written with Python language. The Jupyter Notebook is original web application for creating and sharing computational document. So I have downloaded the fraud detection demo. There are several directories and notebooks. I have executed 2 notebooks in advance. The first is experiment train. This notebook it trains the AI model and saves the AI model locally and encrypt the AI model. The second notebook is it uploads the AI model from local to S3 storage. Next, I will share a little more about the detailed steps. When it trains the AI, how it train and gets the encrypted AI model, install the Python dependencies, load the CSV data, build the model, and then train the AI model. So the model is trained ready. It will save the model to the local file. You can say that this is a model name. Then it tests the model. So I would explain a bit more about example. This example is checking seller's transaction likely to be fraudulent or not. Here is the data. The distance from last transaction is 0.3 and ratio to median price is 1:9. The user used the chip and didn't use the PIN number, and it's the online order is 0, so it's an offline order. Analyzing this data, the AI model predicts that it's not fraudulent, and how likely was seller's transaction to be fraudulent. It's very low number, so that's why it's not fraudulent. Next, now we get a well-tuned AI model, and next for the CoCo part, we need to encrypt the AI model to test the CoCo. So we use the fancy to encrypt the AI model, and the key is k.bin. Now the model is encrypted successfully. Now we get 2 models. One is plain text model, the other is encrypted model. And next we will remove the plain text model and only leaves the encrypted AI model. Okay, so the next notebook, it uploads the encrypted AI model to the storage. It installs the required packages, defines the function for the upload, and then upload and check. So the model, the encrypted AI model, is uploaded to the S3 storage, and you can say that this is a model directory, models fraud. We will use it in our one serving the model. Now we've got the encrypted AI model. Let's serve it in the OpenShift AI page. Models, deploy a model. Model name, let's call it fraud. Serving runtime, OpenVINO. Framework, model framework. Existing connection, this is where the model is served. Let's choose the storage which our AI model is uploaded, and this is a model path. Now let's deploy the AI model. So let's switch to the pod and the fraud detection. Here you can see that we have our fraud predictor pod is running. It is in the init phase, and the fraud detection pod is is our workbench, is for the pod which running in the workbench, and the main IO is the S3 storage, is running the S3 storage. So the fraud predictor, this pod is serving the AI model, and however it had errors, this is expected. Let's check the logs. There are several containers inside this pod, and the init container storage initializer is I will explain what it do and why it fails with the default runtime class. So the storage initializer, it downloads the encrypted AI model from the storage, and then it will retrieve the key from the trustee. After it gets the key, it will use the key to decrypt the encrypted AI model, and then the AI model will be able to served by these containers. However, with Trustee, it will fail. Sorry, I should check the logs here. Let's say the raw format, which is a bit clear. So it's copying the AI model from the S3 storage and then download it to the local pod. However, when it retrieves the key, you can say here is the error. It fails to retrieve the key. This is because the Trustee pod is not in a TE environment, and it fails to perform the attestation. It fails to get a key, so that's why the encrypted AI model cannot be decrypted. So the init container cannot exit with success. So that's why it always hit errors. Now let's change the runtime class to kata-tdx. Now let's edit the runtime class. Sorry. Fraud detection. Sorry, not this one. Here, disable the external to work around an issue. Change the runtime class name. Add the runtime class name as kata-tdx. Now let's say the pods and the fraud detection project. We can see besides the fraud predictor 01, we also have a new pod which called fraud predictor 02, and this pod is running with the kata-tdx. It's in the init phase. Let's check the storage initializer log. Let's check the format, the raw format. Yeah, it copies the models from the S3 storage and download it locally. Then it will retrieve the key from the trustee. 100% progress, and now it gets the key successfully, and the file can be decrypted. So we get an decrypted AI model. So with kata-tdx, the pod can retrieve the key from the trustee, and the AI model can be decrypted. Get back to the pod. It's in the pod initializing phase. During this time, we can check the YAML file. Let's confirm the runtime class. We can see that the runtime class name is kata-tdx. And now let's also check the logs from the trustee. Let's say the trustee logs. Here is the trustee operator system, and the pod is trustee deployment. Let's check its logs. The KBS logs. Still says in the format. Yeah, here is a log. You can see it's using the attestation. The attestation service is Intel Trust Authority, the ITA, and it get resource from the KPIs. It get the K is kata-tdx. The resource access request passes the policy check. So the KPIs released the K to the pod. Now let's get back to the pod page. It's pod initializing. This will take a bit while. This is because the total size of images is about 7 GB, so it's a huge image. It will take more time to start up the pod. Now we can see that the pod is running, so this means that this AI model has been served successfully. Here the status is as expected is successful, and we can get inference endpoint. Let's copy this inference endpoint and let's try to submit the data to via the REST API to this link. Let's copy it. And in the Jupyter notebook, let's open the REST request notebook. So we paste our inference endpoint link to here, and let's run request. This is a request function. Here are two examples. The first example is that the user buys a coffee. So the transaction data is the same location as the last transaction, so the distance is 0. Same medium price as the last transaction, the ratio to medium is 1. The user is using a PIN number and using the credit card, and it's an offline transaction. So by analyzing this data, let's say how the AI model predicts. The model predicts that this is not fraud. Okay, so the next example is fraudulent transaction. So let's say how what's the fraudulent transaction? The data is that someone stole the user's credit card and is buying something online. The data is it's very far from the last transaction. The distance is 100, and the median price similar to the last transaction. Ratio to medium is 1:2. Not using a PIN number, not using the credit card chip, and is an online transaction. So let's say how the AI predicts by analyzing this data. It should be here. The model predicts that this is fraud. Okay, so I think that's all the demo. A summary is that when we deploy the fraud detection encrypted AI model with a non-CoCo environment, it will fail to serve because it fails to retrieve the key from the trustee. When we run with kata-tdx, it can get the key successfully from the trustee after perform the attestation, and the encrypted AI model can be decrypted and can be served, and the AI model works well. That's all. Thank you.